Okay, our topic today is 4D, natural logarithms. Natural logarithms is a special type of the logarithms. So let's look at what is the natural logarithm. Before we talk about natural logarithm, we need to talk about the natural exponential function. Natural exponential function is y equals e to the power of x. In this exponential function, the base is an irrational number, e value. So this value, we all know this value is around 2.71828, blah, 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 something. Okay. And the natural log function is its inverse function. So I interchange x and y and solve for y. So the function is y equals log x in the base e. For this base e, log ex also can be expressed by ln x. So this one is pronounced as ln. So this one is called ln x. So the inverse of the natural exponential function is also called the ln x. If you guys want to graph both of these two functions on the same coordinate system, okay, we can graph both of them just here. Natural exponential function is an increasing model because the base e is larger than 1 and it pass through 0, 1 point. And y equals 0 is the horizontal asymptote. With the line y equals x, its inverse ln function, which is the natural log function, is the reflection image of y equals e to the power of x in the line y equals x. So its graph should look like this way. It's still an increasing model. And this one passed through 1, 0. And it has a vertical asymptote, x equals 0. Okay, natural log identities, just like other log identities. We know log a base a to the power of y equals y. So if I change the base a to e, so it becomes ln e to the power of x. This one is the same as log e to the power of x. And we know this value is just the x value. So this one is a to the power of log ax is x. So here e to the power of ln x is the same as e to the power of log ex. I just change base a to base e. So this one is x. And a to the power of x, so this x, I can change this one to a power of e as well. So this one is e to the power of x ln a. So which is e to the power of ln a to the power of x. Okay, right now let's look at how we can use the second identity to write the following in the form e to the power of k, where k is corrected to 4 decimal places. We need to change this 50 to e to the power of what? The second identity, let me know, okay, x is the same as e to the power of ln x. So this 50 is the same as e to the power of ln 50. What is ln 50? Let's use the graphing calculator to find ln 50. So we turn on the calculator. So ln value is here. 50, enter. So it's 3.9120 with 4 decimal places. So this E, okay, 50 is equal to E to the power of 3.9120. The same idea for the second value, 0.005. If I want to change this one to an exponential form with base E, it's E to the power of ln 0.005. Ln 0.005 is negative 5.2983. So this power is around E to the power of negative 5.2983. Okay, so right now let's look at how we can find the x values in the ln equations. Ln x equals 2.17. This ln is actually a base E log. It's the same as log x in the base E, equals 2.17. If I want to find this argument value, I can change this log form to the exponential form. So base E, this log value is the exponent. So E to the power of 2.17. On the graphing calculator, we can find second ln, which is E to the power of 2.17. So this value is 8.75. 8284041. Anyways, if there's no requirement in the question, we always keep 3 significant figures in DP math course. So this E to the power of 2.17 is around 8.76. The same in the second one. Ln x is a base E log. So this x value is E to the power of negative 0.384. Use the calculator to help you find the approximate value. So it's E to the power of negative 0.384, which is around 0.681. 0.681. Laws of natural logarithms, the same as the product law, the quotient law, and the power law. So for this base E logs, we still have those 3 laws. Ln AB equals ln A plus ln B. Ln A divided by B, this is the quotient law. We can split this quotient into ln A minus ln B. Dividing becomes the minus. And this is the power law. Ln A to the power n, we can bring this n to the front of the log. So it's n times ln A. So those three laws are natural logarithm laws. Let's use the natural logarithm laws to write the following as a single logarithm. Ln 5 plus ln 3. Adding between these 2 logs. So we know we can multiply the arguments and put on one log symbol, which is ln. So 5 times 3. So this one is just ln 15. Minus in the middle, we know this is the quotient law. So it's ln divided these 2 arguments. So it's ln 24 divided by 8. It's ln 3. Ln 5 minus 1. We need to change this number 1 to the base E log, which is ln. So this one is ln E. So minus in the middle, this is a quotient law. So this one is 5 over E in the ln. Example 4, use the laws of logarithms to simplify. 2 ln 7 minus 3 ln 2. That means we need to convert these 2 longs to one long. So you know that this one in for C already. If you want to combine these two logs into one log, you need to get rid of the coefficients in front of each log. So we can use the power law to bring those coefficients back to the exponents. So it's log 7 squared minus log 2 cubed. 7 squared is 49. 2 cubed is 8. What's the minus between them? So this is the quotient law. So log 49 over 8. You can put in the pair of brackets to show the entire argument. 2 log 3 plus 3. If I want to combine these two logs together, I need to change this 3 to a base E log, which is log. So we know how to change a constant to a log with any base. So I will change this 3 to 3 times 1. And this number 1, in this case, with the base E log, is just log E. Then I bring 2 and 3 both back to their individual exponent position after the argument. So it's log, so this one should be 3 squared. So this is log 3 squared plus log e to the power of 3. With the plus in the middle, we know we multiply these two arguments. And the 3 squared is 9. So it's log 9 times e cubed. You can put in a pair of brackets to show the entire argument. Show that log 1/9 equals negative 2 log 3. So the left side is log 1/9, which is the same as, I can bring this negative 1 to the very front first. It's negative log 9. And the 9 is 3 squared. Then I bring this 2 to the front and multiply it by this negative 1 in front. So it's negative 2 log 3. So let's look at this B. How can I show this left side is equal to this right side? Log 500. This left side can be converted to 1000 divided 2 because I have a log 2 in the subtraction. So I want to make a 2 in the denominator. So log 1000 divided by 2 is log 1000 minus log 2. You can use the graphing calculator to find the log 1000. So log 1000 is 6.907755. Okay, if you round up to 4 decimal places, so you need to round up. It's 6.9078 minus log 2. Okay, the last example in this lesson. Write the following equations without logarithms. Let's look at how we can get rid of the long symbols in both of these two equations. So we have log A, which is a single log on the left side. So on the right side, right now I have two terms. I need to convert both of these two terms to one log. So 2 log C. For number 3, I need to convert this one to log, which is log e to the power of cube. Okay, I'm not so sure if you guys still need a detailed explanation on how I converted 3 to log e to the power of 3, because I will take the 3 as 3 times 1. And for this number 1, I change it to log e. Then I bring the 3 back to the exponent for argument e. And the same for this coefficient 2, I need to bring this 2 back to the exponent. So it's ln a equals ln c squared plus ln e cubed. On the right side, with the plus in the middle, I can multiply the arguments by using the product law. So it's c squared times e cubed equals ln a. Now this time, I have one log on the left side and one log on the right side, and both of them have the same base e. Then I can get rid of the log symbol and the base. So the arguments must be equal. So a equals c squared e cube. Okay, I want you guys to have a try to get rid of the long symbols in the second logarithm equation. So on the left side, there is only one log. That's awesome. Then I need to combine these two logs on the right side. The same idea. I need to convert this number 2 to a log first. That's 2 times 1. It's 2 times ln e. Then I bring both of these two coefficients back to the exponents. So 3 goes to the back, become ln a cubed. 2 goes back to the exponent. This will become ln e squared. This is ln m. With the minus in the middle, we know this is the quotient rule. So we need to divide these two arguments. So it's a cubed divided by e squared. Then one log on the left side, one log on the right side, and both of them have the same base. I can ignore the long symbol and their base. So it's m equals a cubed over e squared. So here is the homework.